CentOS system that's been copied. So the same commands are going to work, not like 100%. So I know we stopped, last class, we stopped at the current file. And this is essentially how you could schedule your machine to do work for you. So I'll just go back so we can just a review. Remember the format where we have the minute, the hour, the day, the month, and the day of the week. So this is essentially a cron. You won't really have to use it a lot, but when you start using a system like Jenkins, Jenkins has a built-in plan. It's the same idea, but you're not going to have to use this same concept. This is predominantly Linux. And we're going to, so now today we're going to talk about user management a little bit. So as you can see, the etc password file, you see right here, this is where you can see your users in your machine. So if you cut the etc password file, every user that you have on your machine, even you, admin user root, you should be able to see them. So you're going to see something like this. You're going to see the name, which is root. You're going to see this X, 00. So essentially, this is telling, when you see an X, it's telling you that the password has been encrypted. Because normally, this X is what was going to reveal the password for you. So for example, in my Mac, if I cut etc password, I should see every user on my machine. You see that? It's a user database. This is a user database. So there's a nobody, which is an unprivileged, is a root. This root right here is a root user, the administrator. And then you have all these other users that are very, do it on your machine, run cat etc password, and you see every user that's on your machine. The user, the UUID, and all that stuff. You should be able to see it. So that's just how you can go on a Linux machine and just to quickly see what users you have on your machine. If you create a user, that's where you go to see it. And then we have, since the machine like this root, when you see that file, this root is a username. The X is a password. It's encrypted. That's why you see an X. And then this is a UID and this is a GID. So this is a user ID and this is a group ID. So the user ID and the group ID for root is 0, which means it's the most privileged user, pretty much. And then you have your comments. And your comments could be like the name of the person that has a file. And then you have your shell. This is your shell, your bin bash. So it just tells you the default shell of that user. So it's just simple concepts to keep in mind. You can go practice, just have that in the back of your mind. And then if you want to look at the actual passwords, you have to go to the etc shadow file. Any password that's encrypted will be stored in the etc shadow file. So, and you have to be root user to be able to access that file. The etc password file, anybody can read it, but the etc shadow file, you have to be root to be able to read it. So you have to, those using CentOS, cut the etc shadow file and you should see an output. So someone want to cut the etc shadow file? So this is it, cat etc shadow. Let me know what you get, guys. You see, my shell is still using the old method, where it used to be, the user data used to be stored in what we call the etc password. But now all new systems are using etc shadow. So cut etc shadow. If you don't see anything, try cutting etc password. And you see all the users. And you even see their passwords. So this is just basic user management, in case you're wondering where your users were. But when you start doing DevOps, most of your user management will be done in AWS, right? You mostly be doing your user management in AWS. And you can occasionally go into Linux instance to look at the users and manipulate those, but you don't really have to worry about it too much. But it's good to know where you can actually go into the Linux system and see your user, see your password. And then you can know if a user is present, user is absent, and things like that. So these are just important concepts. And then this is one of the options that we have to use. So if I wanted to create a user, it's just user add. You want to create a user on your Linux machine. User add and the username. And then the -c is a comment. And you want to use the -c to put like a name to that user. Basically, so you use -c to put a name. And then to create a home directory for that user is -m, and you can specify. And then -s is when you want to give the path. But you don't have to. If you put user add, username is going to inherit the default path, which is bin bash. So I want you to try that. Try creating a user. I'm doing it on my machine. It's just user add. User add, that's it. And then you put the username. I'm just going to put my name. Let me just put it now. So try user add. So those using the old shell, you should be able to do it. You have to, me, I'm using the Mac, so some of these commands might not work, but you should be able to do it on your CentOS. So user add and the username.
I tried mine, it said permission denied.
Oh, maybe you have to be a root user, that's why. So try sudo su and then put your password. Did you put your password? Try sudo su.
Yeah, I did that. It came, it said password for admin user.
Yeah, put the same password that you use to log in.
I know, but when I type, it's not going through. It's not typing.
Yeah, when you type the password, when you're typing password on Linux, it won't show you.
Oh, okay.
Yeah, it just keeps it blank, but it's receiving it.
Yeah, I did.
All right, so try using that user add again. Let's see if it works this time.
Okay, good. It says root. Yeah, it says root localhost admin.
So if your user add, if you created a user with user add, if you cut your Etsy shadow file, so your Etsy, if you cut your Etsy shadow file, you should be able to see your user. Let me show you that command. But what we're missing is we still have to create a password to that user so the user can be able to log in. So if you cut your Etsy password file, this file, Etsy password, you should be able to see a user in that list.
Okay. Yeah. Yeah. How do I exit from here? Just click exit.
Yes.
Okay. Yeah, that's good. It popped up. It brought some lot of things like.
So this is what you can do. Remember the grep command that we practiced the last time? You can use grep to try to find out if your user is in that group. So let me show you. So you can say, okay, cat. This is how you say it. Do cat Etsy password, right? And then space pipe. And then you grab that and then -i and then you put the name you're looking for. Whatever name, like if it's Linux, that's how you do it. And grep will be able to search that file to see if you have Linux in there. So you have that. So what I'm doing is, did you search and did you get any information? And then to create you have your user. Let's say you created user add. So I'm going to bring up an EC2. I'm going to bring up a system here in a minute that will be a normal CentOS. And the practices are going to go better. But when you have that user, the way you can create the user password is to use this. Let me show you a command. So now that you have your user, now you want to give that user a password. So this is a command, password, and then the user's name, and it's going to prompt you to put the user's password. Password, and then the name you use as your username. And that's how you launch your password. That's how you give your user a password.
Oh, so I've now it pulled up. So I now put the password for the person.
Yes, the password you want that person to have.
Okay. So do I just put the Mimi and then click enter?
Yeah, press enter. It's going to
password.
prompt you again, and then you type again.
Wow. Yeah, successful.
Yeah. So now that user has a password. So you can log in with that same user if you wanted to.
Oh, wow. Okay.
So as you see here, guys, what you're seeing on my screen right now is I'm logged in the cloud. So we're going to learn this in the future. As you see, but you see this sign, just something to keep in mind. I'm using SSH, and I'm logging into a system in the cloud. We're going to, when we do AWS, I'll show you how to do this. So, but just keep in mind, SSH-I is, I'm using a key pair. And a key pair is like your secure, what we call an encrypted file that you use for all your machines. So no one can go into your machine if it doesn't have that file, right? So when each instance you create, you're going to create a key pair with it. So this is a key pair I'm using, and then this is the name of the user and that system, add, and then this is a system, this is the public DNS name. We're going to talk about this, but I just want you to know that what you see now is not my Mac shell. This is a machine I just created in the cloud, essentially. And I'll be using it for practice because this is going to have everything I need. So if I hit enter password, you see, it's totally different from the command I had before, just because I'm not using my local machine. I'm using a machine in the cloud. So as you can see, these are my users. So now we should be able to practice with no problem. So now, let me try that user add again. User add Linux. You see the same thing, Ramesh, you had, right?
Mm-hmm.
Yeah, it's because I'm not the super user. So sometimes we use, for cloud machines, we use a word called sudo. So sudo essentially is like saying that I want to act I want to act as a root user, but I'm not a root user. So there's a file called etc sudo. So you create that file, and for example, this is let me just give an example why this file is important. Let's say you have Bajo, you have Ramesh, you have William in the system. You don't want them to have access to your root user, but you want them to be able to do things as a root, right? I'll create that file, and I'll put Ramesh, Bajo, William, and everybody else in that file. So they can be able to use the sudo to act like a root, but they're not actually a root. So it's like a way to secure your system. So not anyone. So sudo is what you use most of the time. You see, now it works. So you get used to this, and keep in mind, remember this command, sudo, because once you start working in the cloud, you're going to need sudo to be able to act as a root user. If you try sudo, Ramesh, you're back to your user, right? If you try user add Linux or user add whatever, see if it gives you that same permission issue, and then try sudo and see if it works. You see that?
Yeah.
So Bajo, you see how I was able to cut that file? And trust me, I can change the color of this shell if it's too, I can change the background to maybe black. If that will help, let's see. Let's see. See what's the color. Maybe a more black shell will have more. So that's what I'm doing. I'm creating a dark shell so you guys can be able to see better. So let's see. Is this better?
Yes.
Yeah, I'm creating a. So this is better. So what I'm going to do is I'm going to go back into that file and see. Watch. The reason why I'm going to the downloads folder is because that's where my key pair is. Remember this file? The file you have to use to create you see that? That's an encrypted, this is all encryption. So this is what makes my systems unique. So if I have to log into the cloud, if I don't have this thing in my SSH, it's not going to let me in. So this is essentially your security, this encrypted file. So if you notice right here, I put SSH dash, and then this is a file. The file I just open here. I'm supplying this file, and what I'm telling them is, I own this system. That's why I'm able to have this file. So can you let me in pretty much? And it's going to let you in because you have access to that file. You see that? I'm already into the system in the cloud, so we can practice. So this is just some of the concepts that you keep in mind. You know, most people don't know how to do this, and there's no way you can do DevOps with that. So we're going to learn this essentially when we get to cloud. So anyway, so I did user add, and I created my user called Linux. And to check, I wanted to check the Etsy password. Remember this file, this file. Remember this file, Etsy password. Whenever you create a user appears in this file. And if you look right here, right in the bottom, you see Linux, that's the file I just created, that's the user. And now I want to give a password to my user. I'll just put password and then the name of that user. Only root. So whenever you start command only root, I'll use sudo. You see now new password, I'll just put any password. And with this user, you can be able to log into that system too with it. So when you create this user, whenever you you open your machine and it shows admin user and asks you to put a password, you can go back and say, I want to put a username and a password. And you use this username and password and it should let you in. But you know, when you're doing DevOps, this is like on the granular level. But as a DevOps engineer, you're working with user management from the top, like from AWS itself, which we're going to study. So this is just some of the tricks. So now we have our user logged in there. So that's how you create users in Linux. And then the next command is now there's a group. Each user has a group, and these things are easy. They're so easy. You know, it's usually they made Linux so easy that everything is one command. Everything is one command. So if you want to look at the groups in your machine, you can just cut this file, the Etsy group. So if I cut Etsy group, I should see all the groups, the user groups in my machine. You see that? I have a root group, I have the sys group, you know, I have all kinds of groups in here. And you can add users to any of these groups. And remember the user I just created? They created a group for it right here. So Etsy group is where you find all your groups for your users. And if you forgot what group is, remember this command? This is our user, and this is the user group, EC2 user. And if you look into this Etsy group, you're going to see that group EC2 user in this group right here. You see this group that you cut in the Etsy group file. You just cut Etsy group. This user you see right here is the same user, that is the same group that you see here. So the username is EC2 user and the group name is EC2 user, and this is the group right here. So most of the files in this directory are owned by the EC2 user and also the EC2 group. So that's just essentially what it is. It's not too complicated, but when you know things like this, it really broadens your knowledge of Linux and how Linux works. Trust me, when you start working, you're not going to use any of this for the most part. But every now and then, you could be in a situation where you need to check the groups and the users. But you just have to keep this concept in your mind that in Linux, you can manage users, you can manage groups, and you can manage anything you want. Just keep that in mind. And then this is obviously the command to add a group. So group add, and then the name of the group. Is that easy, guys? Group add, and then the name of the group, and you create a new group. Group add the name of the group. Group add the name of the group. That's it. Linux is pretty easy. The hardest part of Linux is just knowing the commands. But in the most part, the commands are pretty easy. So if you create group add and then create a group, and you cut the etc group file, you should see that group that you just created in there. So let's see, group add. Group add. Okay, sudo. Okay, so if I cut etc group, I should see my user in there. So this is the group that I just created right here. So the video will be there for you to practice, but this is just user management in Linux. I would just be, all I recommend for you is just to do 1 or 2 practice, go back, create a user, create a group, you know, and just little practice, and that's all you need. You don't need to do too much with this, you know. That's all you need, just understand how it works, you know, and you create groups, and now you can start, you know, adding users. So this is a small exercise I want us to do. So this is a small exercise, just to practice. You can do this exercise now. So I want you to create the following groups. Create a group for writer, group for TV, and group for movie. Did we create the users? Did we create the groups for writers, TV, and movie? So what I want you to do is, let me know if you've created at least one of the users.
Yeah, I created all.
Oh, okay. So now I want to show you how you can create a user and assign that user to a particular group. So to create a user, I know I have the papaya group that I just created here. And I'm going to create a user called papaya, and I'm going to add the user to that group. So user add, right? User add. And then to add a user to a group, this is the command you use, -G. User add -G. And then you give the name of the group. In this case, I'm giving the group, I'm saying I want you to be in the papaya group. And then now I need the username. And I'm just gonna give, so this is how, and I should probably use sudo. So you can do that for your writers group. You can create a user and make sure and add that user to the writers group by doing this. Sudo user add -G is a group. -G is saying this is a group I want that user to be in. So you put -G, put writer, and then you put the username. If the user already exists, so you can do that for user that already exists. You can add that user to a group by using group add. But then now you're creating a user and adding them to a group. So you're using it as G. So, oh, the group, I made a mistake. It's not papaya, it's papapa. Okay. Okay, so now I added a user to my papapa group. So if I cut my Etsy password file, I should see that user there, and I should also see that user, the user I just created, to have the UID of my group. And remember, if you cut the Etsy group file, Do you see this UUID here? 102. When you look at your user, all right, the user I just created, you see they have 102 here. 102. That's the same for our group right here, Papaya, which is 102. So that's how you add the user to a group. And you can do this to multiple users. But yeah, this is just, just keep that in mind. We're going to talk a little bit about networking. Today, I want us to really wrap up Linux. And like I said, feel free to go back and watch the videos to really wrap your head around it. But we just talked about user management. When you go back and watch the video, you can be able to pause the video and practice. Pause the video and practice. So, and then you can skip the video if you want. You can watch the video at 2 times speed. That's what I do most times to be able to cover more ground. So anyway, we're going to talk a little bit about networking because it's important. So networking essentially is one of the most annoying topics in Linux, man. Even I, for one, I don't like networking because, it's easy, but at the same time, it can get boring really quick. So anyway, this is networking. So in our system, the way machines communicate with each other, they communicate using what we call IP addresses. I know we all know what IP addresses are. If you don't know what IP address is, let me know, right? So we can clear that up. So TCP IP is essentially how a machine is able to communicate with each other. So if you look at this command that I used, I'll come back to it, but it's essentially the same concept, but I'm using, instead of using IP address, I'm using a host name. So I'll show you the difference. So this is TCP. So TCP is used for all the network communications you have on your Linux system, how they're able to communicate with others. So like your TCP is your transmission control protocol, and then your IP is your internet protocol. So your IP is what is going to allow you to connect to a particular machine, send information to a particular machine, right? And then TCP controls your data exchange between files. So if I wanted to send information, if I wanted to send a file to a machine, I need the IP address of that machine. Otherwise, I won't be able to locate that machine to send anything from you. So you use your IP address to send data from one machine to another. And then you have your host. Your host is essentially what's keeping your machine. For example, now, when you look at this share right here, I told you I'm working in an environment in the cloud. This machine right here, this is my host. It's an EC2 machine in the cloud. So this is my host, essentially. So networking is just something to wrap your head around. It's actually a very important concept, but wrapping your head around is as important. So this is an example of an IP address. You have your 199. So you have a quartet, right? Each separated by a dot. So that's how all IP addresses are. You have the first set, the second, the third, and the fourth. Every IP address is a quartet. And then you have something called subnet mask. So the way the subnet mask is, it's totally an opposite. I would say opposite from, if you have an IP address like a class C IP address, like this one, we're going to look at the classes. Your subnet mask is always going to be 255.255.255.0. Same if you have a class A IP address, your subnet mask will be 255.0.0.0. So we're going to see, and then you have something called a broadcast address, and that's how other machines can be able to see you, in a pool. So essentially, it's a broadcast. So this is what you show everybody. Say, okay, this is how you can contact me, guys. This is my broadcast address. So as you see, there's an octet to make an IP address, and it can be from 0 to 255. So this is essentially the classes that you have when you're doing a little bit of networking. So you have a class A, which is anything from 1.0 to 1.27.0, and that can have up to 16,000 IPs. You have a class B, which is 1.28 to 1.0, all the way to 191.255. This one can have about 65,000. So what this is essentially tell you is, when I have my big network, or my class A network, I can have my class A network if I wanted to have multiple IP addresses. Like I want to have up to 16 million. But if I don't want that, I could just use a class B to be able to use a smaller IP address range. And you could use class C if I just say, okay, whatever I'm doing, I only need 255 IPs or less, and then use a class C. That's how you'll be able to conserve your IP addresses. And guys, some of these concepts are going to look sound a little bit, but once we start doing some of that work with DevOps, you see how important this is. So this is what we call a CDR. It's called a classless interdomain routing. So CDR is essentially the amount of IP range that you have in any system that you're working with. So, for example, if you have a VPC in the cloud, your VPC is going to have a CDR. It's going to have an IP range. When we start talking about VPC in the cloud and subnet, you see how from your CDR range, you can start creating subnets off of those. It's like you're just reducing it. You have an IP address of 16 million. You can start breaking those out into smaller chunks and creating subnets. So that's essentially what it is. So remember, the only thing I want to remember what the CDR is. It's a classless interdomain routing. So just remember that word, because when we start doing cloud, you'll see how we're using CDR and how we're creating VPCs for CDR. So yeah, just keep that in mind. And that's the only thing I want to, when you look at this, I want you to remember this word CDR, because we're going to use that in the cloud. It's a classless interdomain. So it's telling you the entire IP range that you have, how many IPs you can have, how many the subnets that you can have in that IP and things like that. So just keep that in mind. So in order to see your IP address of the machine, you just type IP address, or you could type IP space A. It's going to give you the IP address information of your machine. So if I type IP address, you see that? Just type IP address or IP-A, and you see the entire IP information. So as you can see, I'm on 127. This is the local host, and you have your broadcast. You have some very important information here. You have your INET, scope, and you have different things. But you type it and tell me what you see.
Yeah, that's what I see. Link, INET.
Yeah, so you see this IP here, right? This is your IP address. So if I wanted to, like, for example, you remember how I was able to log into this machine? I use the host name, but I could also log into this machine using this IP address you see here. But this is a private IP address. Usually when you want to log into this machine, you want to use what we call a public IP address, but this is a private. So which means that if I'm in the same network with this machine, I can be able to ping this machine with this IP address. That's the location. So if I wanted to send something to this machine, this is the IP address I'll use. So whenever you're confused and you want to see IP address of a machine, just type IP address and it'll show you all the information. So you can do this for any system, right? So that's a small trick to just see your IP address, and another thing we're going to talk about is the FQDN, which is a fully qualified domain name. So as you can see here, there's a webprod01.mycompany.com, walmart.com. That's a fully qualified domain name. So, and then every fully qualified domain name, they have a top-level domain, TLD. TLD is a top-level domain. So it could be .com, it could be .net, .org, anything. There's hundreds of them. I've seen all kinds of I've seen .org. You could have anything. So that's a top-level domain. So as you see, for your fully qualified domain name, your top-level domain is .com, right? And then you have your regular domains. It's to the left of your top-level domain. So to the left of your .com, you have your webprod.mycompany. That's your domain. The domain, just like if you have walmart.com, Walmart will be your domain, and then .com will be your top-level domain. And then to have a fully qualified domain name is walmart.com. So it's fully qualified. So it means that if you take that and put in your browser, you should be able to see walmart.com. So it's a fully qualified domain name. And then we also have something called subdomains, and we'll use that a lot. For example, I can guarantee you now, class, that you see walmart.com, there's a lot of subdomains that use walmart.com. For example, if you have walmart.com, if I wanted the subdomain for walmart.com, I can put staging.walmart.com. So as you see here, webprod01, you see that little dot before the my company? That shows you what the subdomain is. So it's like you can use one domain like walmart.com, and you can create multiple domains off of it and use it to test. For example, if you have walmart.com, if Walmart wants to do tests on walmart.com, they're not going to use walmart.com because that's the production. That's what the consumers or the users use, So they're going to use a subdomain off of that walmart.com. So I could say, okay, I want a staging environment, a testing environment where I can test. So my test environment will be something like test.walmart.com. And then they can use that now to do their tests. or stage.walmart.com. And they can trust me, all companies have that. And I guarantee you, Walmart has stage more qualified. They have subdomains that are attached to walmart.com to do testing and things like that. So just to keep that in mind, just keep in mind what the fully qualified domain name is, what the domain is, because those are things as a DevOps engineer, you have to understand those domain names because sometimes you'll be managing them. And I'll show you how to manage them on Route 53 when we start doing AWS. So if you type host name in your machine, type host name and you should see your host name. Type host name in your machine and you should see host name. There's many commands. Host name, you could type uname -n or you can even type host name -f. So I'm going to type host name, just host name. You see what my host name is? You type host name and you see a host name.
Mine didn't pop up. You see, we have to type just host name or host name -f.
Yeah, anyone. You can type host name or you can just type host name -f.
I just type host name. Mine says localhost.local domain.
Yeah, localhost. Localhost is your home machine. So me, I'm in the cloud, so it's giving me an actual host name. But you're working with your local machine, right?
Yes.
So it's going to give you localhost. If you're working with some machine in the cloud, we'll give you the IP. But since we're all using our machine, for example, where is that? Let me open another shell here. New tab. So this is my local machine. Let me type host name and see if you see what it's going to give me. You see that? I type host name and just give me my MAC. If I cut what we call the etc host file, you see, this is where you can see all your host names. See that local host? 1.7.0.0.1. This is telling you that this is a local machine we're working on. And you can see the broadcast and all that. So that etc host file is where you see all your information about your host name. And that's where you can change your host name. You can change everything in Linux. So yeah, I was just talking about this, but this is, guys, let me promise you guys, networking is not the most fun part, but it's very important that you understand networking because everything you do on the internet, if two machines cannot communicate with each other, then those machines are useless, you know? How is Walmart useful? Walmart is useless if people can't access walmart.com. So that's all about networking. You know, so you have to understand networking, even though it's the most boring, this is my most boring thing I ever know in Linux, but you just have to understand the concepts of how networking is, how machine communicates. So if you cut your SE host file, you see your aliases, you see your different, so that's where you can easily change your host name. So if I go into my SE host file, I could be able to change the host name on my machine. Yeah, you could change your host name on your machine using an SE host file. Yep. So every Linux system, it has an XE host name. So this is a sample file. I know when you cut that file, you saw something like this, right? 1.27.0.0.1, that's your local host. If you come and you change, you add an IP here. Let's say I add, 10 point whatever, and then I put a different name. This name, what you have on the right, this is a host name, and it's translating to this IP. So essentially what's happening here is webprod01.mycompany.com. If I can access webprod01.mycompany.com, just like I'm accessing 1.2.1.6. So it's essentially the same thing. And this is why we talk about DNS and all that. So back in the day, when IPs came out, you don't expect people to master all these numbers, right? This is too complicated. So that's why we created host name. So instead of me remembering 10.1.11.30.7, all I have to remember is DB cluster. And it's going to direct me to this IP address. Just like Google. Google.com is an IP address. But because you can't remember the IP, they changed the DNS name to google.com. So when you're accessing google.com, you're accessing an IP address. And the google.com is just a host name. That's helping you, so you don't have to master all this complicated. So that's just the concept of networking. Whenever you access any website, walmart.com, Costco.com, any website, you're accessing an IP address. But this IP address is hidden behind that Costco.com. Just so because if you access the IP address of Google, it's going to take you to google.com. But you don't want to remember that. So use something called host name to be able to mask that IP address. So all systems you see, They masked the IP address in the back and using what we call DNS service. So this is something that you have to keep in mind. When a service starts, it binds into a port. So these are some of the ports, the most common. So you don't have to worry too much about ports, but you just have to remember these particular ports, like port 22. If my port 22 wasn't open, I would not be able to access that machine that I just accessed in the cloud. And if you want me, I can show you that in more details in the cloud. I'll show you. And then you have 25 SMTP, 8 is HTTP, and then HTTPS is 443. So when you type https://www.walmart.com, what it's doing is it's taking you to walmart.com and it's opening this 443 for you. That's essentially what's happening. And if walmart.com blocked 443, no one will be able to access that website. So this is your port. So ports are essentially protocol. If you go to a machine, so let me explain what port kind of looks like. So when you have an IP address of a machine, right, the port is what shows you that even though I'm logged into this IP address, this is a particular service I'm trying to access. For example, if I wanted to see a service running in port 80, I'll put the domain name with the IP address, and I'll put / and then I'll put the port. So this is what I mean. If I wanted, let's say I have an IP address of 1. This is my IP address. If I wanted to access the port, I'll just put a dot and then put 80. It means I want to access port 80 of that machine. But a port like port 80 and port 443, no, you don't have to put them in. They're automatically locked in the machine. So let me open my cloud instance and show you guys and drive. So do you see here? So this is a machine that I'm logging into, right? And if I go to the security groups, you see what is this? This is port 22. Yes, if I didn't have this port 22, I would not be able to log into to SSH to that machine because this is a machine that controls this. So if I remove this, let me show you a quick example real quick, how ports work. So this is my SSH, right? I'm going to delete my SSH. I'm going to delete this 22 in that port, my SSH port. So this is what's going to happen. I'm going to delete it, and then I'll save it. Watch what happens. You see, my machine logged me out. See, the machine logged me out. If I come here I try to, the machine logged me out. Yeah. So let me try. If I come here and I do my SSH as usual. Where is it? If I come here and I try to do my SSH, let me duplicate. So if I try to SSH into that machine, is this my downloads? So if I try to SSH into that machine right now, you see I'm using SSH and SSH port is 22. So if I try to SSH into that machine, see, it's hanging. It will not let me in because I closed that port. I basically closed that port to the public. That's how you can protect certain systems, certain ports. So it's not going to let me in. But then I'm going to go back and I'm going to, edit my inbound rules, and I'm going to add my SSH. And I'm going to say, okay, I want anybody from anywhere. Well, I could just put my IP address. I could say, no, I only want my IP, only me to be able to access that SSH, right? And I save it. Once I do that, it should be able to let me in now. You see that? Now it lets me in. Yeah. So that's essentially what the port is. That's what the port will do to you. So this is just me just trying to see an idea of what the port, how it works. So now it lets me in. Now I can do my work. So when we do SSH, when we do cloud, you see how we do that more often. But yeah, that's a very important concept, what I just did by removing and adding. So many times when you're working as an engineer in the cloud, you have issues where people can't connect. And the first thing you look at is the security groups, which I just opened. But I'm going to talk about that more once we start doing cloud. So this is just more concept. I promise, I say, guys, please go back and watch these videos, just so you can familiarize yourself with some of this. But, Etsy services is just where you can see your ports in your machine and that are open. So cat Etsy services. You see that? All kinds of pods are open in my machine, for my local machine. And don't forget the grep we talked about. You can use grep to search. So that's all the pods that you have in your machine. Trust me, some of them will be open, some of them wouldn't be. But that's how you can access the pods on your machine. So this is another cool feature. You have to remember this feature. When you want to test connectivity from your Linux machine, you use the command ping. So you can ping anything. You can even ping Google. Try pinging Google and see what happens. So I'm going to ping. You can ping any website to see if you are able to access that website. So if I ping google.com, you see, it's telling me that I'm able to access google.com because I'm sending packets and I'm receiving the same packets. So if you logged into your machine, you can cancel by Control-C when you're done. So you can ping any website. If you ping and it tells you that packet lost, it means you don't have connectivity to your machine. So this is how you can start to diagnose problems in your machine, guys. Well, let's say you're at work, right? And someone called you from work and say, we can't access this system. We can't access that system with this IP address. When you log into your machine, the first thing you want to do is try to ping that machine. When you ping it, and if you don't get any response back, you know there's some connectivity issue, right? If you get ping back, and then you know, okay, it's not a connectivity issue, it's another problem that we have to deal with. So this is one of the cool diagnostics commands. So ping is just to establish connectivity. You can do this to any website to see if you can be able to access that website from your machine, pretty much. So keep in mind, ping is a very important. You use that at work to test connectivity. So ping, that's what you use ping for. And then you can also tell ping that, okay, I only want you to send 3 packets. If you want to limit and you don't want ping to keep pinging and pinging, you can say ping.c and then you put how many packets you want to send. And then you put the host name. So for example, I have this guy here. I just want ping to send 3 packets to Google and see if Google can receive that. So I'm just going to put 4. Let me just say 4. So it's going to send 4 packets and see if Google see 2, 3, 4, and you should stop there.
Mine keeps pinging. So how do I stop it?
Control-C.
Control-C. Okay.
So if you don't want yours to keep pinging, this is where you use the -c command. Ping -c and then say 4, and then you tell the machine, I want you to only do 4 pings, and then stop.
Mm-hmm.
Guys, we're learning some cool stuff. Yeah, keep this one in mind. You're going to use this, I promise you. If you're in IT, you're going to use ping. Always. You're always going to use ping because it's very important. This is another one that you can use. Traceroute essentially is tracing. So, okay, let me tell you what traceroute is. So let's say you have google.com. Whenever you type google.com, normally sometimes you go between different locations or you can go through different. So to see where all my networking is going, say when I type walmart.com, am I just going directly to one server or am I bouncing between servers? So traceroute will tell you exactly where your packet is going, how many services is hidden. Like you can see the traceroute google.com, as you can see in the screen here, it was able to diagnose some network connection. You see, 1, it took 0.296 seconds to access this address. And then number 2, it took 2.5 seconds. So it was able to hit multiple IP addresses. The traceroute is just one of those diagnostics tools that you could use to be able to trace where my connection went. If you have an issue with the system that you don't know what's going on with that system, you can trace the route and see where it's hitting and see where packets are getting lost or things like that. And this is another command that I use a lot. So next start, these are just nice troubleshooting commands that you have to keep in your tool set when you're working with Linux. Let's start. And I always tell you, with all these commands, they have different options, but usually just master one option that does everything for you. So for net start, I have my net start, and then I use TULP. TULP. And that's what that one always gives me everything I need. So for example, if I wanted to see which ports were open on my machine, I type net start and then dash TLPN. You see that? It tells me what protocols are open on my machine. It tells me the address, and it tells me if it's listening to it or not. So that's another cool command. Just keep that in mind, and you can go do a little bit of research, guys, if you want. Just Google it, net start. But these are the commands that I use the most when I'm trying to diagnose problems. And you can just do a little bit. Like I said, the only way you know this is by practicing, going online and searching those words and doing more reading. Because when you start working in the IT field, you have to be able to do research. Because most problems you face, the answers are online. You have to be able to know how to Google. But anyway, guys, that's it with networking. I promise you, go back and watch this video and do more practice. But that's it about networking. The basic concept of networking I want us to remember, because networking is very important. So now we're going to take a break, and then we're going to talk about this cool feature called scripts. And we're going to do a little bit of, show you how you can write a little bit of programs on your Linux. Not programs, you can write a little bit of what we call scripts to do work for you. So remember, you can run commands and you can run commands on Linux to do anything. You can also put that in a script and let that script run for you. So when we come back from break, we're going to look at scripts and see how we can write scripts. And you see some cool stuff with shell scripts, guys. So let's have a 10-minute break. There we go. Is everyone back?
Yeah, we're here. I'm here.
So I see Ramesh, you here? Felix.
Yes, I'm here.
Felix, William.
Yeah, I'm here.
And then our star will say, oh, nice. So today we're going to continue our class, which we're on pace to actually wrap up Linux for now. And remember when I used to tell you that everything you do is in Linux? This machine that you see me working on, you see this is a Linux machine. Everything you do at work is going to be on a Linux machine. And you'll be similar machines like this that you have to log in and you have to do your work on it. So that's why Linux is so important. And you have to be able to CD, to see files, and all that stuff. You see my home directory is empty, but I can see some hidden files, see my .bash profile. I know we talked about the .bash profile. That's where you can make things persist. So if I cut that .bash profile, you see some my path, this is my local path, and once you say export path, any command you put on your .bash is going to stick on the machine when you restart, whether you restart the machine or not. So anyway, so let's talk about scripts. So this is going to be your best friend as a DevOps engineer. You don't have to be a DevOps engineer, even a database administrator. Let me switch on the lights. Even as a database administrator, or anything in IT, you have to know how to write scripts. And when I say scripts, what I'm referring to is what we call a bash script. So all the command that you write on your desktop, all the command that we've been practicing so far, we can put that in the bash script as well. ls, cd, and all that, we can put all those in the bash script and we can run them. So a bash script essentially contains a series of commands. It has an interpreter that executes the command. Most bash, we call that the shebang, which you're going to see. And anything you can type at the command line, you can type in this, you can put it in a script. And it's great for automating tasks. Guys, I can't emphasize how important the script is. It's great for automating. So you can use a script to automate repeated tasks. And you can pair a script together with a cron to have machines running all the time for you. So this is an example of a shell script. So remember, each time you write the shell script, the name of that file has to be the name of the script and then .sh. And the sh, you're telling the machine that this is a shell script. That's very important. So if I name a file Linux, I have to put linux.sh. So you're telling that this is shell script. And each shell script starts with what we call, a comment and then an exclamation. And this is what we call the shebang. So you have a shebang, you have the /bin/bash. You're telling the machine that I want you to run this as a bash script. You can do this for any. So when we do a little bit of Python, you see that for Python, you have /bin/Python. So you're telling the machine that this is a Python script, this is not a bash script. So we can quickly do a bash script. So what I can do is I can quickly do a bash script. So for example, you see my machine, I'm going to open up a file called echo.sh. You see here, and the first thing I want to start is with my shebang. And then I have bin. Oh, why is it blue? I know it's hard to see. Can you see that?
No, not really.
Yeah, I don't know why. Why is it? I don't know why my VI is blue. But, and then I put echo. So my bin bash, what you see here is this, my shebang. So guys, I want you to open up a file, any file, and name it, naming it a .ch. Open up any file, VI or anything. Open up a file and type. First of all, start by doing the shebang, and then when you finish, you go to the bottom of that same script and you type echo script in front.
I have a quick question. Sorry. So on the Oracle VM VirtualBox Manager, have you installed anything new, or are we still using the CentOS manager?
It's still the CentOS.
Okay.
So when you see this script, all I'm telling this machine is I want you to echo. I can also tell the machine that after you finish echo, I want you to do an ls-la, right? And then I could tell this machine that when you finish doing your ls, I want you to echo again and say, finish my ls-la. These are normal commands that you run on the shell. But now you want to put it in a script, right? So now when I'm finished, I'll say, okay, I'll do my normal escape WQ, colon WQ. And now I want to execute that file. And the first thing you want to do is you want to convert that file into what we call an executable. So remember the shmod, right? So and remember an executable is a 1. So you could put 766 and you could turn that file into an executable. Or you could just put plus X and then you put the name of the file. And X is saying that, oh, I want this file to be an executable. That's the easy way. That's how I do it all the time. When I want to quickly convert the file to an executable, I just put shmod plus X and then I put the name of the file. And you automatically change that into, and then to execute, you just put a // and then you put the name of the file. You see that? It really executed. Remember, the first thing in that file was to echo running a test. And then the second thing was you told that shell to do an ls, and this is a ls. And then the third thing we did was, let me cut that file so you can see. We told the machine to echo, we told it to echo running a test command, right? And this is it, it echoed it, running a test command. And then I told the script I want you to run ls.ls. I want you to list the contents of this directory. And this is it right here. It told me I have a total of, this is it, the ls it. And then I said, when you, at the end, after doing that, I want you to echo finish my ls.la. And if you look here, you see, this is it that I echoed here, ls.la. So can you guys, you can start seeing the possibility of what you can do with this shell scripts. So instead of typing these things, I can just put them in the script and I can execute them over and over again. If I do this, I can execute the same script by doing this. You see? It just keeps executing the same commands. Each time I execute that script, it does the same thing. Any questions?
Oh, I just got here. Oh.
Yeah, so we're talking about shell scripts essentially. So a shell script is just any command you run on the command line, you can decide that, okay, I don't want to type this on the command line. I want to put it in a script and run it every time. You can put the same commands in the script. Like I said, these are normal commands that, for example, I want you to do this on your machine. Type echo and then open two of these, brackets, or how do you even go? So type echo running a test command on your shell, and it's going to echo running a test command. If you type ls.la, it's going to list everything. And if you type echo finish my ls.la, it's going to echo that to the screen. And that's essentially what I put in the script, and the script did the same thing. So we're going to go back, we're going to see a few more examples. So this is another example, but this is if you want to run a Python. Remember, for bash script, we put shebang bin bash. When we start doing Python, we're going to put user bin Python. And this is where the executable for Python will be. So just to keep that in mind, that this bin bash means a lot. It just tells the machine that I want you to use a bash to run that command. And your bash is essentially what you're using. But if you want to run a Python script, you're going to use user bin Python because that's where the Python executable is. And you run a Python script. So just keep in mind that this thing is actually important, because if you run a bash script and you forgot to put this, the script is going to run. But for your machine to be consistent, you want to put this so your machine, any place you run your script, is going to know that I need to use a bash. So that's the way you control. If you don't put this, some machines that don't have bash, or some machines that the default shell is not bash, the script is going to fail. So you're telling the machine that if your default executable is not bin bash, I want you to make sure you use bin bash to run the script. Just like here, you're telling the machine, I want you to use Python to run the script, the Python executable. So that's essentially what it is. So we're going to do a few examples, a few variables, and see how you can use variables in your script. So, for example, let's say I have a few things that I want to add to my script. So I'm going to open that same script. And in my script, I wanted to store an information. Let's say I want to store the name of the, or you could store anything in your variable, right? Let's just say I have a variable called boy. And inside my boy, I want to store the name of all the boys in the class. I want to store Ramesh. I want to store Bajo. I want to store Bajo and maybe Nelson in that variable, right? So now each time I call boy, I'm essentially calling Ramesh, Bajo, and Nelson in my script. I know we talked about variables, and this is how you can use variables in your script. So now that I have a variable called boy, I want to list the contents of boy. So you use this, and you use something we call a $sign, and then you just put boy. Or you could see, or you could just echo it. You could say, okay, no, echo. I want you to echo the contents of boy. And the machine will automatically know what boy is because you saved it in this variable right here. So this is in programming. So this is just introduction to programming, because when we do Python, we're going to use things like this a lot. So I'm just introducing you to Python. So a variable in Python is a container where you want to store a certain file. So for example, let's say in my script, I wanted my script to have a few names. I wanted my script is going to use a few names. Like for example, my script is going to use Felix a lot. And I don't want to keep typing Felix, or any other thing. I can store that in a variable. And you can do that on the bash script. So as storing the variable is as easy as putting the name of the variable equal, and then in those in these two brackets right here, in these two, and then you can just store the variable. In these two quotes, in these double quotes. So you have boy equals to, and then the double quotes, and then you put whatever value you want to store in that file. That's how it's easy as it is to create a variable. So we created a variable called boy. I'm going to create a variable named girl. And it's that easy, guy. Just put the name, open your quotes, and I'm just going to type some names, some female names. So I'm essentially storing everything. So whenever I open girl, I'm going to have Tanya, that complete list is going to be my variable. So now I want my script to use that variable to echo. So to echo that variable and to be able to display what we have in that variable in the screen. And you can use this variable, you can use this to do any kind of interaction you want to do on your system. So for example, now I'm telling the machine that I want you to echo. I want you to display what's in that boy variable. Right? That's how you do it. I'm going to remove this line because it brings a lot of noise. So let's see how the bash script executes. So I'm going to execute the bash script. You see what it displayed? I'm going to cut that file real quick so you can see. So I told the machine, in boy, I'm storing Ramesh, Bajo, and Nelson. In girl, I'm storing Emily, Tanya, and Vanessa. And I say, okay, echo boy, echo girl. So just display the contents. And look at what they did here. Display the contents of boy, they display the contents of girls. So that's the concept of variables, how you can store values and you can use them in the future in your script. So that's just the basic idea of variables. Remember, go back and watch this video and try to practice. And yeah, so you see, you were able to echo the value of that variable here. Someone created a variable called my shell, and he stored in the bash. And then use echo $, the name of that variable, and it gives you the value. You see, the outputs are like the $sign. It's going to echo, instead of the my shell, it's going to echo bash to your screen. So this is another thing you can do with the script, with the shell. Remember the commands that we've been writing? For example, hostname. Oh, so if I type, let me go back to that bash. If I type hostname on my machine, you see, it gives me my hostname, right? Any command is not just hostname. Remember any command, like, I don't know, if I type date, it gives me the date, right? You could take this input and store it in a script as well. You can store it as a variable. So let me open that script and show you. So this is my script. So what I want to do is I want to store the date when the script ran. I want to store it in a variable. So I'm going to put date equals to, and then I'm going to just put that command. So the way you do it is you put $, the open bracket, you put whatever command you want to run. Like for this particular thing, I want to run the command date. Remember, it's lowercase. And what the machine is going to do is it's going to store that date command in that date variable. So each time I call date, it's going to show me the date, pretty much. So you get the concept? So scripts are so cool. This is what you can do with scripts. So now I want to say, I say echo $date. I want you to tell me the date. I want you to display the date variable. I want you to display, it has to be caps, because remember, variables are case sensitive. So I want you to display the contents of date, which is this value. So you can store anything in a variable. You can even store ls-la into a variable. You can store any Linux command in a variable, anything. So now I'm going to save, and I'm going to run that command and see what it tells me. So let me cut that file so we can see the file open. That's the file. And then let me try to execute it and see what it tells me. You see that, guys? You see, instead of displaying me, display the date. You see that? It's Sunday, January 16, and even displays the time in UTC. So this idea is for you to understand that you can store anything in a variable. Anything, any command, any Linux command, and then you can use that. For example, if I wanted to attach that name, let me show you how I can use this date variable in a script. So now I have my date, right? Now, what I want to do is I want to take that date and I want to create a file in my home directory, or I want to create a directory. I want to create a directory called Linux, and for that directory, I want to store, what do you say? I want to store, how do you call it? I want to append that directory, that name, Linux, with the current date, so that whenever I come, I know exactly when that file was created. So now I have my date. So you see that? So what I'm doing is I'm appending my date to my Linux. So what I'm telling this machine is I want you to create a directory, make Dree called Linux dash. I want the name to be Linux dash the date. So each time you create a directory and attaches the date to it. That's how you can start controlling files to make sure that I know when this file was created, right? And imagine you had every file with a date. You know exactly when that file was created. So this is one of the ways that you can. So let me run that script and see if it creates a file. So guys, do we see a file with the date on my machine? You see it?
Yes.
Yeah, exactly, right? Let me show you that file. Right here.
Linux.
Sunday, and it has the entire date. It has the entire date. If you look here in this script, you see the entire date. You see, if you don't do like an ls, you see there's Linux, and then there's a date, Sunday, UTC. You see that?
Yeah.
It created it with the date. So that's how you can start manipulating files, using variables to attach to your file. You can take any variable and use it, you know, to different man. So you see what I'm doing? You can use that date to do any other thing you would do on any Linux platform. So this is the power of shell scripts. You know, you could use a shell script to create a directory or a file that has a date on it. And then now you could start storing things into that file, right? And you could do that every day. So each day you come, you say, okay, today is Sunday. This is the files that we created. Monday, this is the file that we created. For example, let me open that file, and then now that I have my directory called, I have my directory with the date. Now I want to store some things into it, right? I want to touch a file. I want to create a file. So I'll touch a file called linux.txt. And then what I'm going to do is I'm going to touch that file, and I'm going to copy that file or move that file into my new directory that I just created. So guys, I just want you to start understanding how you can use. So this is what I'm doing. I'm essentially running two commands in one. I could just do this. In fact, to make it easier, I'll just move that to the bottom line. Like that. Guys, it's the same commands that we've been running all day, right? Move, to move a file into a certain directory. So move the file name, linux.txt, into this directory right here. So this is what I'm telling the machine. Create a variable called boy, store this, get date, store it in date. I want you to echo boy, echo girl, echo the date. I want you to make a directory called Linux, the current date. And I want you to create a file called linux.txt. I want you to move that file into our new directory. Okay, that's what I'm telling the script to do. And you can start to see how you can automate basically anything on Linux. You can do this, you can make your life easier, because any command you run on Linux, you can put in the bash script and you can run it. So let's see if that script does what we need to. We might have to make some changes. But yeah, oh, the file already exists. So let me remove that file and then I'll run it again. Okay. So I'm going to let's just create another file name. I'm gonna just use Lino. And I'm going to execute the script. You see, what it's telling me is it's probably already created Linux, probably. Let me cd into that Linux directory. So yeah, so as we can see the errors, it's telling me that the file already exists. And the file already exists, so if the file already exists, there's no point creating it. So you can go back into your Linux, which we're going to talk about, how you can control your Linux and be able to tell you that if the file already exists, or if the file already exists, you don't need to create it again. You can just use the file that exists. So we're going to, when we start looking at conditionals of a shell script, you start seeing. And guys, I just want you to be familiar with this concept, because once we start doing a little bit of Python, it's going to be the same concept of manipulating scripts and just just creating scripts and using them and doing other things with it. So anyway, so we have that. We just talked about variables, how you can store variables in a file like hostname. You can echo, the same output. This is the valid variable names that you can use. So you can start with the letter and then followed by a number and letters to have a variable. You can have underscores in your variable. You can have, but what you can do is you cannot start your variable name with a number. Or you cannot start your variable names like this. So this is like the no-nos of variables. So the first add is invalid, because first is a reserved word, right? First is a reserved word. So you can't use something like first. You can't use to create a variable name. And you can't start your variable name with a number. So that's just essentially the two things that you can do. But you can use anything to create a variable name. So let's talk about the if statements that you can use in your shell script. So in my shell script, like for example, we just had an issue where the saying that the file already exists, right? So now your if command is just what you're doing is just checking to see. You could check any test. I could check to see if that file already exists, and if the file already exists, I want you to skip, right? That's your conditions. When you say if, you put whatever command you want to test, and then you say if that's true, and then I want you to run this command, run this command, run this command, and then you can close it with an FI. So that's how you can start using conditionals. For example, we're gonna use this on our script that already exists, and try to see if we can tell you that if the file already exists, I want you to proceed and do this and copy this and copy that. So let's go back to our script, and let me see if there's anything we need to talk about. So these are other things that we can use to compare. You can compare one argument to another. You can compare argument one and say, if this is true. So you can use all this. So we have this in the script. So if I have an argument called argument one, and I have an argument called argument two, I could test and say argument one dash EQ argument two. What I'm trying to tell the machine is, I want you to check if argument one is equal to argument two. If argument one is equal to argument two, then you return true. Otherwise, return false. And the way I can use this in the script is I can say, if argument one is equal to argument two, I want you to run these commands. Else, I want you to run this other command if they're not equal. So this is how you can start using, you can say, oh, if argument one is less than argument two, I want you to do this. So you can do this with numbers. You can say, if this number is less than this number, I want you to do this. If it's greater than this number, I want you to do this. So these are all conditional. So we're going to try to use some of this soon. So this is an example shell script. So what you're doing is you're telling my machine, you store the variable called my shell, and you named it bash. And you're telling a machine that if the variable my shell is equal to bash, which it is, then I want you to run this command. Just echo this, and then you close it. So this is like the most basic way you can use if. So I'm essentially testing something that's already true. Remember, I stored my shell as bash. So I'm just using if to check to say if is my shell equals to bash, which it is, as you can see here. Then I want you to echo this. So this is like one of the basic tests that you can do to test to see if your machine. So let me go ahead and just do this real quick, so you can see it in real life. So let's see. I start a variable called shell in bash, right? And I want to use the if command to check if shell is bash. So remember, guys, the command is, as you see, this is how you type it. So what I'm testing if my shell, which is this, is equals to bash, then I want you to do this. So essentially, I'm saying if $shell, which is this one right here, it has to be $. If $shell is equals to bash, which it is, as we can see on the screen. If this is equal to bash, right? Then I want you to run this command, run this command, run this command. And here we're just gonna, then I want you to echo. So we're just gonna echo. And I'll go back and I'll make it false, and we'll see what it's going to tell us. So then, and then space is indenting for me, which, I love you. I love you trying to indent for me. As you can see the indent here, but, echo, what was that? You seem to, we could type anything we want. Well, echo, your shell is bash. And then FY. So I start my variable shell as bash. And then I ask the machine, if my shell is equal to bash, what is this? And then I want you to echo your shell is bash. And then I want you to exit. So let's execute that script and see if it echoes that to us, or if there's an issue with our script. You see, it was able to tell us that, yes, your shell is bash. Let me cut that file so you can see what that file said. That echo. So we'll tell the machine, if my shell is equal to bash, I'm telling the machine, if shell is equal to bash, I want you to echo your shell is bash. And that's exactly what you did. You echo your shell is bash. So let me go back to that machine. Let me go back to that same bash script and change the value of shell. Okay, I changed it to basha. So automatically, it shouldn't echo anything because the shell is not equal to bash. So I changed it, and let's see what it tells us now. You see, nothing came to the screen. Why? Because the shell is no longer bash. I changed it to basha. So now it's not going to echo anything. So that's one of the conditionals that you can use in your script. So this is it. Let me tell you an example where you can use this. Let's say in your file, you have a file in your machine that you're supposed to have that's called back or back. You have back here. But now you're writing a script and you want to use back, but you're not sure if back is available. So you can use if, and then you're going to use something called -f, and then you put the name of that file, which -f is then is checking to see if that file exists. You said if the file exists, I want you to put this in the file. If it doesn't exist, then I want you to create that file before you put in the stuff in it. So this is how you can start to control your errors on your machine and things like that. So we're going to see if, and then echo, and then if is wrong, we're going to see how we can display another output if your bash is not equal to, or if your shell is not equal to bash. Let's say my shell is equal to basha. And I said, if my shell equals to bash, I want you to echo this. But what if my shell is not equal to bash? What do you want it to do? So now we're going to see what we call the if else. So now I'm telling my machine, if my shell is equal to this, I want it to do this. Else, you're telling the machine that if it's not equal to this, I want you to echo this instead. So let's go back to that script and let's open it again. And in that script, we have if my shell is equal to bash, and then echo this. But remember, I changed it from bash to basha. So now it's not going to be able to give me that output. But now I want to tell the machine and say, else. Then I want you to give me another output. Else, echo your shell is, and then I'm just going to put whatever we have in that variable called shell and display it to the screen. So it's going to check, is your shell bash? And then echo this. If my shell is not bash, then it's going to echo your shell is, and it's going to echo whatever I have in this shell. So this is just normal programming concepts that I'm just getting used to, because once you start doing Python, you have to use all of this kind of arguments. So I'm going to execute that script and see what it tells me. You see, it checked to see what the bash was. The bash wasn't shell, and then I said else. Let me cut that file so you can see the context. I said if shell is equal to bash, but shell is basha, then echo your shell is bash. Else, echo your shell is the name of this word is basha, and you can see right here, he echoed your shell is basha. So that's conditionals. That's how you start using conditionals on your shell script and start making decisions. If I go back and change that, if I go back and change my shell to bash, here. Oops. If I change my shell to bash, and then you should be able to, oh, I have two dots. You should be able to echo me your shell is bash because I changed it. So we're going to execute that script, and what I'm expecting to see is it telling me that your shell is bash. You see, your shell is bash because I changed it to bash. So this is those little concepts that you can use to write the shell scripts. And guys, I think we're going to practice more. You should go back and just any command that you can use on Linux, right? Just put in a bash script and just run it. And you're going to see it's going to run that same command for you. So this is how you can automate tasks in your Linux shell. So there's if this command is true, then I want you to use this command. Else, I want you to throw this command. And then there's another word that we can use that is called else if. So you can use else if to pile commands upon commands upon commands. But I think that if you get the concept of use my shell and then do this, else do this, and then you're getting there. And then this is the last one, which is else if. So essentially, I'll say if my shell is equal to bash, which is not, then I want you to echo, you seem to like the bash shell. Else, if my shell is equal to say, then I want you to echo, you seem to like shell. And then else. So remember, you're always ending it with else. So you're using elif is when you want to keep using commands upon commands upon commands upon commands. So else if, and then the last one is always going to be else. So as you can see, this is how you can chain multiple commands together. And then this is the last concept we're going to talk about, which is going to be like your for loop. So this is how you can iterate into any variable that you have, right? So for loop is a way of you running through a few variables. Remember, we created a variable called boy, and we had a few names in it. You could go into that name and pick up each name and echo it to the screen. Each name and echo it to the screen. So this is a for loop for you guys. So you store your items in a list, and you could go through that list and do whatever you need to do with those items. So I'll show you how to do that in a minute. And this is an example where you can store, color. You say for color in red, green, blue. I want you to echo color, and then you put the color. It's going to go into this list and echo red, green, and then blue, step by step. You can see the output right here, color, red, color. So what you're telling this machine is, for color in red, green, blue, you're telling the machine, I want you to save red, green, blue in color, and then I want you to go in that, and each one of them, I want you to iterate. It's like what you're doing. This is very important, guys, especially when you start doing advanced, because sometimes you have a list of files that you want to go in there and use those files to do different types of activities on your machine. So now, instead of typing each file, you can just loop through the file and say, I want you to loop through this file. And for each file, I want you to output it to the main, or I want you to do anything. So I'm going to do an example of this real quick. So let's open back that file, the bash file I have. Okay, so I'm going to create a variable right now called boy. In that, I'm going to store, everyone in class right now. I'm going to store Felix. I'm going to store William. I'm going to store Nelson. And I'm going to store Bajo in that file. And I'm going to store, where else am I missing? Ramesh. So this hypothetically, this is a file that you have. And you want to search through that file. And you want to do something to any of those outputs I have here. So what I want to do is I want to look through that file. I want to list every name in that file, one after the other. So I'm just going to go for, for name in, and then I'm just going to put echo boy. So this is the way you're telling a machine that this name you see right here is going to represent each value here. Each time it loops through. So essentially what you're telling your machine right now is, in boy, when you look at the first value, Felix, I want you to store it in the name, and then I want you to do what you need to do. And then come back. The next one will be William. I want you to take William. I want you to do what you need to do with it. And then when you finish, come back and take Nelson. I want you to do that until you're completely done with the entire file. So this is how you can store things in the machine, a variable anywhere. You can look through them and not have to type them every time. So guys, if you don't understand, man, feel free to ask me any questions, but these are just concepts that you go back, watch the video, and then if you have any questions, But these are just important concepts because you're going to use shell scripts. And when we start doing DevOps, you're going to see me using shell script a lot to connect the dots. Scripts like this, to do installations, to do simple things in Linux. You're going to see me using shell scripts. So just understand the concept of shell script, what you can do. Know that any command you run in Linux, you can put in a shell script and run it as well. You can automate it. So that's a big concept I want you. So we have our for color in whatever I do, and then the simple command that you add after is just do. Do, and then you have a bunch of commands that I want you to do. So in this case, I want you to list, or I just want you to list this file line by line.
Can I jump in for a question real quick?
Yeah, sure.
So the for loop right here is kind of like repetition of something. Like normally in C or C++, like for this to be this, probably for it used to be in how do I put it? Just kind of like it goes with a while loop and it repeats itself.
It repeats itself essentially. Yes.
Yeah. So is that the same thing here?
It's the same thing. And when we do Python, you see that we still use for loop in Python. So this is like a basic, introduction to writing just little programs. So again, let's go back. I'm telling my machine that for name in boy, so name, it could be anything. I could say for list, I could put for B, anything. This is just a placeholder. This is just a placeholder, guys, for whatever is going to search in this list. Evelyn? So, guys, you tell the machine that for name in boy, I want you to, this is what I want you to do. I want you to echo each name here, close to the word name. I want you to list his name one by one. So that machine is, what I'm expecting the machine to do is to go into that loop and list every name one after the other. So let's see, let's execute that script. You see, what is missing now, it executed the name, but it didn't execute the value. So now we have to go into the script and try to diagnose why. So when I look at this script, I can immediately tell that the issue with this script is probably either I'm missing a comma or I'm missing a bracket. So we're going to do a few changes. And this is how you diagnose scripts, guys. You have issues with script. For example, I'm going to try the first fix. And I'm going to use oops. I'm going to take out the brackets. And then see what it says. So let's take this out now. Let me execute that script one more time and see what it gives us. So it's telling us we have an error on William. So we'll go back in there and I'm going to try to diagnose and say, okay, what is this machine? So maybe it's because I need to store this in a bracket, or maybe, but essentially I could take this to make this command easily loop through this command right now. Another way I could do it is I could just copy that and put that in here.
So is the for loop not going to have a bracket in its front?
Yeah, so you could also do this and it's going to still loop. But yeah, but you could store that in a variable as well. But let's try this and get what it says. We'll keep having errors. So like you can see, you can say, for example, like you see this example, this guy, you can just for color in, you can just put and then you can echo and it's going to echo you using our $sign. So what do we have here? Oh, I see where the issue is. Oh, okay. Guys, I'm surprised no one picked this up. I'm putting name here, but I'm supposed to be putting boy. Guys, I'm expecting you guys to start picking things like this up and just point it to the screen. which means that you're paying attention.
Oh yeah, you listed the wrong variable.
Yeah, I listed the wrong variable, guys. Pay attention, guys.
We paying I don't know if it's just me, but man, I'm totally lost. I'm just following. But I might go back and watch the video.
Yeah, go back and watch the video.
I don't know if it's just me, but everything you've been doing so far, I'm just looking.
Well, there we go. So now it's listing all the names. So what I want you to do is to list one name at a time, right? So I want you to list one name, but you can see it's listing Felix, William, Nelson, Bajo. So it's going in and listing the entire names at once, but I want you to list one name at a time. So let's go back in there.
Can I ask a question real quick?
Yeah, sure.
Yeah, if you're just echoing that, what's the use for the for command then? Because doesn't echo just literally echoes everything that you do? If you're just echoing it, why do you need the for command?
Give me a second. So say that again, my bad.
Sorry, I'm saying if you're just echoing it, from what I understand, echo simply means display, right? Like display whatever is up there. So if you're just echoing it, why do you need the for command then?
Well, what you need the for command is essentially what I'm saying is you're trying to list it one at a time. So you're trying to look through and say, okay, for name, echo name, the first name, I want to do Felix and then do William. But if you use echo and then just put boy, it's just going to list you Felix, William, like you just did, right?
Oh.
But now, what I'm trying to do is I want it to go in there and do one after the other.
One at a time, yeah.
That's what we're trying to achieve, yeah, one at a time, instead of just echoing the entire thing.
So without the for, it will just list it in the straight line, just like it is now. Without the
the for. So let's keep troubleshooting this and for in Felix. So let me just do it how it is in the script, in the documentation. But Ramesh, I get it, man. This thing can get complicated. You know, even me, you know, I do these things all the time, but sometimes I still need to go back every now and then and look at them and just try to familiarize myself with them. So now, I see. Another thing that we didn't pick up is, remember, guys, I'm supposed to be listing the name. I'm not supposed to be listing the actual variable, because everything is stored in the name. Let me put that into. Yeah, so I mean, I like things like this. You see now, I like things like this because when you're troubleshooting, you know, it helps you to see little mistakes. So now he's listening one after the other. The first one was Felix, second one was William, third was Nelson, fourth was Bajo. So it's going there. So now you could use the same logic to look through any file. So I'm going to go back to my variable here, and I'm still going to do the same thing, but now I'm going to store that. Instead of doing all this here, I'm going to store in my variable. I'm going to look through my variable, which is boy. So I'm going to look through boy, and my expectation is it's going to give me the same output. See, it's listing one after the other. First name Felix, second is William. If I went in there and put the first to be William, it's going to start with William. And now with a list like this, I can start doing different things with it, right? I could say, I want you to echo, not just echo, but I want you to echo this and store in separate files. I want you to echo this. So the idea of this is just to tell you that you could look through a file, or you could look through a document, you could look through anything and be using them to do multiple tasks. Like I could create, let me show you an easy thing. I could create a file for each name in this list. Watch this. I would say, okay, I want you to, each time you loop, I want you to make a directory. That is the name of that file. So what I'm saying is, when it's done, I'll use a sudo. What I'm telling this machine is, when you loop, I want you to create a directory with that name. So let's see. Okay, so you see, there's a directory for each name.
Mm-hmm.
Yeah, so that's how you can start to use shell script, guys. You could use it to do anything you want to do. Now you're creating directories. You could be something you're doing with those values. So I'm just giving you an example on how you could use shell scripts to do all kinds of things, guys. It helps you. It helps you a lot because now instead of typing make D Felix, make D Nelson, make D Ramesh, make D William, I use one command and I just look through and create directory for all the names without having to write them individually. So yeah, that's one of the cool things, you know. Shell script is so nice, guys. You can use shell script to do literally anything on your machine. Any questions?
It's not easy, but we have to.
No. Bajo, this is the last part of Linux.
But how do you exit the script real quick? Sorry.
The VI,
Yeah.
you hit, first of all, when you're in the script, when you're already typing, you hit escape and you hit double colon. Let me go back there. You see my screen. Right? I'm here.
Mm-hmm.
I hit escape, right? And then there's a double colon. Do you see in the bottom?
Yes.
If you want to exit the file without saving it, you can just put Q,
Q.
exclamation. But if you want to save your content, you put WQ and exclamation.
Oh, got it. Thank you.
Yeah, so guys, I want you, this is my thing I'll tell you is go and practice with this shell script a little bit. Any command that you've been practicing from the first day of class, I want you to put in the shell script and let it run. And this is something that I don't want you guys to worry about too much, but I'll just talk about it real quick. I could pass inputs to my shell script, right, from the command line. So if I pass a shell script, a parameter to my command line, the first parameter could be anything. It could be a name. It's going to be stored under $1, $2, and $3 for different parameters. And this is how you can feed information to your script. So let me kind of explain what that means. I have my file right here. And what I'm trying to do is I'm trying to feed a particular name to this script, or I want to feed what the shell is. I want to store shell. I want to be able to feed my machine with shell. So what I'm doing is when I'm running the script, I'm going to supply my script with the word shell or bash to it. And then what I'm going to do is I'm going to take whatever I supply to my screen, and that's going to be my $1. I'm going to store it in my shell script, and then I'm going to come here and I'm going to use that to do any kind of manipulations. Let me show you. So now I'm taking an input from the command line, and what I'm doing is I'm just echoing the content of that into the shell. So $1 is telling me that is the first command, and the second command will be $2, and just like that. So let me quickly illustrate this. So I have my script, and I'm giving something called bash to it on the command line. So we're getting some errors on line 4. Let me open my file. Oh, you see, there's a code right there. So I deleted that. You see, anything I supply to the command line is going to display to the screen, because whatever I sent to the command line, the first command is $1. And if I do bash and then I do shell is the second command I'm passing to the script. So this will be $2. And then if I pass another one, it'll be $3. So this is how essentially I can feed an information to my script and say, use this to do whatever you need to do with it. So let's go back to that file. And what I want to do is I want to echo that whenever anything I put to the screen, I want you to output that your shell is, and it's going to echo whatever I supply to the screen. So now I'm going to use, the first one I'm going to use is bash. You see, it's going to say your shell is bash. So let me supply Linus to the command. See, your shell is Linus. So anything that is supplied to the command line uses it to manipulate. So an example how you can be able to use this in any script, guys, is, for example, you have something running on your machine, right? You have a script that, let's say, does backup of your system. You want that each time you want to run that script, you want to provide your name for your file to store the backup in, right? So I could use something like this and say script, and then I give the name Linus. And what I'm telling the machine is I want to create a directory called Linus. I'm going to store the files in Linus. So I'm supplying it to the command line. So that's just how I do it. So I could put anything right here. I could put Ramesh, and it's going to echo your shell is Ramesh. So this is how you manipulate scripts, guys. You know, I'm sorry for this class. It's a bit challenging because it's the last class that we're going to do for Linux. And we just got to the end. And I want you to go look at the video again, practice the mistakes that I make. And I want you to just follow the mistakes and see how I'm able to go in there and correct them. Because that's how you're going to face the same problems. You're going to have write scripts or anything, you're going to have errors and you have to go in there and find out what's wrong. So troubleshooting is very important. So guys, we've come to the end of basically our Linux course. There's a lot of other things about Linux that we didn't talk about, but I believe that what we talked about should be enough for you to go ahead and do whatever we need to do as a DevOps in practice. So guys, go back, watch the videos, you know, just do a little bit of practice. And next class, you know, I'm trying to decide if we're going to use Python. We're going to do Python next, so we're going to do Git first. It might be smarter to do Git first, but I'll let you guys know. So we're done with Linux, guys. Go practice. And the shell script, like I said, is very important. You're going to see me use a lot of shell scripts to do different things when we start doing DevOps. So you see more, so just go watch the videos, guys. And thank you for joining. Any questions?
No, not really. Just like Ramesh said, it's we just have to go back and see everything and pick up some of the things. You know, you pick one, you don't pick another. That I'm on the same boat with Ramesh. But like I think once we go back and